Good morning, dear students. Myself, Professor Bankar DB, Department of Chemistry, RBNB College, Srampur. For M.Sc. Part 2 Organic Chemistry, in semester 4, the first paper is CHO 450. The name of this paper is Chemistry of Natural Product. So, in this CHO 450 paper, we will see the synthesis, the stereochemistry, retrosynthesis of some important natural product molecule. So, this paper belongs to two sections, section first and section second. So, in section first, the first chapter is understanding and planning of total synthesis while maintaining the stereochemistry. The title of first chapter in section first of CHO 450 is understanding and planning of total synthesis while maintaining the stereochemistry, a case study of Longifoline molecule. So in chapter first, university has given the syllabus of synthesis of Longifoline. So there are total 9 syntheses of Longifoline. For this chapter first, university has recommended the reference book, that is Carey and Sundberg part B. So from this reference, we will see the synthesis of this Longifoline molecule. The structure of this molecule is given. So this is structure of Longifoline molecule. If we observe the structure carefully, then it is observed that it is tricyclic sesquiterpene molecule. Longifoline is tricyclic sesquiterpene molecule because it consists of 15 carbon atoms. Then it is optically active molecule. It is optically active molecule due to presence of 4 chiral center. So we will see the structures of this 4 chiral. We will highlight the 4 chiral centers. So this is 1 chiral center. This is 2nd chiral center. This is 3rd chiral center. And this is 4th chiral center. So there are 4 stereogenic center present in the Longifoline molecule. Therefore, it is optically active. It is oily liquid. This is oily liquid molecule. We will see the numbering system for this given molecule. First, second, third, fourth, fifth, sixth. This carbon carries 7 number, 8, 9, 10, 11, 12, 13, 14 and 15. So due to presence of 15 carbon atom, this is sesquiterpene molecule. So in the organic synthesis, the synthesis of some important and new molecule require multi-step synthesis. So during multi-step synthesis, planning of each and every step is important. So during that large scale or large step synthesis, basically we use deprotecting concept, and also we use synthetic equivalent group. So while using protecting group, and synthetic equivalent group, we can achieve the selective conversion during the multi-step synthesis. So this is about general introduction about the Longifoline molecule. Now we will see the actual synthesis of Longifoline molecule using various ways. The first synthesis of Longifoline was given by E.J. Corey and co-workers. E.J. Corey and co-workers. So there was a group of scientists who developed the synthesis of Longifoline molecule. So we will see in details. So this is Dithiol derivative as a starting precursor for the synthesis of Longifoline molecule. So this starting precursor undergo reaction in two steps. Here we use ethylene glycol molecule and there is Wittig reagent, that is triphenylphosphonium halide. In first step, this diol molecule protect this carbonyl group. Here we have two carbonyl group. This is one and this is second. But this second is conjugated with double bond, so it is more stable. Therefore, selectively this diol protect this free carbonyl group. There is formation of cyclic ketal. This is first step. In second step, this Wittig reagent react with this carbonyl group and there is formation of this type of alkene. So this is simple Wittig reaction. Look at next step. Here in first step we use osmium tetroxide OSO4. So this is well known oxidizing reagent. So this reagent convert double bond into diol. This reagent convert double bond into diol. So there is formation of here OH and here OH. In next step we use tosyl chloride. So this tosyl chloride again convert this secondary diol in this secondary OH into OTS. So in presence of tertiary and secondary OH group, this TSCl convert OH group at this position into OTS. Look at next step. Here in presence of base, for example OH minus, this intermediate undergo skeletal rearrangement happen in presence of base with this particular intermediate, and there is formation of this type of compound. So there is a ring expansion takes place in presence of base. Here this intermediate react with H plus in presence of water. So this protected group undergo deprotection and there is formation of original ketonic group, and also there is formation of this double bond shifted at this particular position. Next step is very interesting. In presence of triethylamine, at higher temperature, intramolecular Michael addition reaction takes place. So in presence of base and higher temperature, intramolecular Michael addition reaction takes place. As we know that in Michael addition reaction, carbonyl group react with alpha beta unsaturated carbonyl group. So in the same compound, here we have carbonyl group and here we have alpha beta unsaturated carbonyl group. So this carbon react with at this particular position. Look at next step. Here we use sterically hindered base. So that base abstract proton at this particular carbon. There is formation of carbanion. That carbanion can be stabilized by the carbonyl group, and then this carbanion then react with methyl iodide. So this methyl iodide is good electrophile. So this carbanion react with methyl iodide and there is formation of second methyl group at this particular position. So we have this type of structure. Last step is first is reaction with chromium 6, that is oxidizing reagent. Sorry. This intermediate then react with this type of 3 steps. We will discuss each and every step. Look at carefully all the steps. Here in first step we use this type of dithiol protecting group. So this protecting group protect sterically unhindered ketonic group. Here we have 2 ketonic group. This is one and this is second. This is somewhat free and this is sterically hindered. So this reagent protect this particular group as a dithiol derivative. In next step we use lithium aluminium hydride as a reducing reagent. So this reducing reagent reduce this carbonyl group into OH. Then we use NH2, that is this is also one of the reducing reagent in presence of base. This is Uhl-Kirchner reduction. So in presence of this type of reagent, this dithiol protected group undergo reduction and there is formation of CH2. So here specifically we make CH2 group at this C5 position. So these are the 3 synthetic steps. So in last some synthetic steps, here we use chromium reagent, that may be CrO3. So in first step OH group at C11 position undergo oxidation, there is formation of carbonyl group. In next step we use methyl lithium reagent. So this is nucleophilic reagent. That nucleophilic reagent react with carbonyl group at C11. There is formation of OH and CH3. In last step we use H+. So there is loss of water molecule and there is formation of CH2 group at this particular position, that is C15 CH2 group formation. So this is synthesis of Longifoline molecule. So here I will stop. In next lecture we will see the next synthesis of this Longifoline molecule. Thank you.